In this video, we're going to look at how to solve how to solve trigonometric equations, but they're trigonometric equations that are in what's called a quadratic form. You may recall from algebra or even from earlier in the semester that a quadratic equation is typically in the form ax squared plus bx plus c equals 0. And typically when you have a quadratic equation, we either solve that by factoring or using the quadratic formula. And one key thing about solving a quadratic equation, which will also apply to the trigonometric equations in quadratic form, is that the equation itself must be equal to 0 before you attempt to solve it. And so we're going to take a look at about 4 different examples of these particular type problems. And so the first one is cosine squared x minus cosine x minus 2 equals 0. And again, hopefully you can relate this back to something you learned in earlier in the semester or in algebra. For example, if you can view this or think about this particular equation, instead of looking at it with cosine, it's like sorry about that. It's like a squared. So we'd have something similar to think about it in terms of a squared minus a minus 2 equals 0. And you want to solve that. And typically we solve that by factoring. I typically do factoring by trial and error. There's lots of methods. To get a squared, we would have had a times a. We need a pair of numbers that will multiply to 2 and subtract to 1. Well, there's only one pair, 1 and 2. 1 times 2 is 2. 2 minus 1 is 1. I need this one to be minus and this one to be a positive. And then we know that one of those pieces had to be 0 to start with. So we're kind of using that same. So we say a plus 1 is equal to 0. A minus 2 is equal to 0. And then we solve each of those respectively for a. So we'd have a is negative 1 or a is positive 2. So we're using kind of that same approach, but instead of using a, we're using cosine. So again, I want to think about trying to factor this problem. So I would have, breaking it apart, it is set equal to 0. So we would have cosine x times cosine x gives me cosine squared. I need a pair of numbers that will multiply to 2 and then subtract to 1 cosine. Again, there's only one pair, 1 and 2. I need the negative 2 and a positive 1. So then I know that one of those pieces, either cosine x plus 1 is equal to 1 or cosine x minus 2 is equal to 0. And I'm going to solve each of those respectively for cosine. So I would subtract 1 from either side. So I have cosine of x equals negative 1. For the other one, I would have, I'm going to add 2 to either side. So cosine of x equals positive 2. So then the question becomes, cosine x equals negative 1. You're really being asked where on the unit circle is the cosine value negative 1. Okay, so that's the question. Where on the unit circle is the cosine negative 1? Your cosine value typically, the cosine value corresponds to the x coordinate of the ordered pair. So if I start looking around my unit circle, you may want to have it handy. I notice that when I get to pi or 180 degrees, that I have the ordered pair -1, 0. So my x-coordinate is -1, or the cosine is -1 at pi units. Okay, so I know that x is going to be pi, and that's the only location where it's equal to -1. So then I have to go back and ask myself, where on the unit circle is the cosine equal to 2? Now, if you look at the unit circle, it is a unit circle, which remember has a radius of 1. If you go all the way around the unit circle, nowhere on the unit circle is the cosine equal to 2. In fact, for cosine, a cosine value for any angle has to be between -1 and +1. Well, 2 is bigger. So for this piece, there is not a solution because cosine of x can never be equal to 2. So for this problem, my only answer is that x equals pi. Typically, now I didn't write the limitations, but typically when you're doing these problems, they want the answers that are in the interval 0 to 2 pi. Okay, so let's look at another one. I have 2 sine squared x equals -3 sine x minus 1. Now, the first thing I notice about this problem is that it is not set equal to 0. So I'm going to do that first. Okay, so I'm going to add 3 sine x to either side, which gives me 2 sine squared x plus 3 sine x, and that equals -1. Again, I'm trying to get it set equal to 0, so I'm going to add 1 to either side. So I have 2 sine squared x plus 3 sine x plus 1 equals 0. And again, at that point, just to kind of give you, again, something to relate it to, this is like having 2b squared plus 3b plus 1 equal to 0. It's like having a good old basic quadratic. It's just that instead of having plain old x, plain old b, or a, or whatever, you have sine squared. Okay, so I'm going to try to factor this particular problem. So I'm going to see if I can break it up. I know that the only pair of numbers that multiply to 1 are 1 and 1. And for 2, it would be a 2 and a 1. So I have 2 sine x plus 1 sine x. And I want to add those together to get a +3. So both pieces are +1. And that's equal to 0. So I know that one of those pieces, either 2 sine x plus 1, 2 sine x plus 1 equals 0, or sine x plus 1 equals 0. And then again, at that point, I'm going to solve each of those respectively for sine. So I'm going to start with sine x plus 1. I'm going to subtract 1 from either side. So sine x equals -1. For the other one, I'm going to subtract 1 from either side. So I have 2 sine x equals -1. Divide both sides by 2. So I have sine of x equals -1/2. Now, here again, you've got to remember that you're trying to figure out where on the unit circle would the sine equal -1/2. Okay, so again, you may want to have your unit circle handy. The sign corresponds to the y coordinate of the ordered pair. So I'm going to scan around and see where it's equal to negative 1/2. I don't see a negative 1/2 until I get to the third quadrant. And in that quadrant, I'm at 7 pi sixth. So one answer would be that the sign of x is negative 1/2 at x equals 7 pi sixth. But I need to keep going. Make sure you make a full revolution because there should be another one. If I keep going, again, looking for negative 1/2 as the y coordinate, I find another one in the fourth quadrant, which corresponds to 11 pi sixth. Okay, so I have either 7 pi sixth or 11 pi sixth. And then I got to go and think about the other one. Where on the unit circle is the sign -1? And again, thinking about where is it -1, again, that's the y coordinate. So scan around the unit circle, and I find that it's -1 when I get to the 3 pi halves, or the quadrantial angle of 3 pi halves. So for this piece, x is 3 pi halves. So you actually have three answers. You have x equals 7 pi over 6, or 11 pi over 6, or x equals 3 pi over 2. Okay, so I hope that you find these particular problems helpful. Again, it's a basic concept related to algebra. You just have to remember to do the factoring.